Pause if necessary, but please take a moment to read the following. Hello and welcome to video 13 from the Kawasaki channel. This particular video is going to be talking about Variacs. I'm going to show you a number of different Variacs, show you how they're connected, what they actually do, and show you what features you might want to look for. We'll also just have a general chat about Variacs in general and dispel a few myths. There are many available Variacs, and on the screen at the moment I have 4. The 2 centre ones at the top are from Amazon or eBay, and they're both under £100, so they're not out of most people's price range. If you're repairing amplifiers, building amplifiers, or repairing a lot of other types of electrical device, a Variac is a very useful tool. These two are quite similar, and really it's down to the individual user which particular features that they like. So this one here to the left has the voltage shown as a digital output. So you turn the control at the top and the voltage going out of these 2 connectors varies with the with this knob. Also on there is the input, which is an IEC. The red Variac, it's a captured mains lead going to a universal output socket. From the look of it, that socket is a UK, US and European socket all combined, and instead of a digital output for the voltage, it has an analog dial. They both have switches to turn the item on test on and off, and the red one has a fuse on the front which is readily changeable. If you want to have more flexibility, then one thing you can look at is buying a chassis mounted Variac. The one to the left, the Ravistat, is a 2 amp Variac, which is basically a chassis mount. So you would build a box, wire this up how you want it wired up, and it would bolt to it. And then obviously you just have the shaft coming out with the knob on it. You'd have to supply your own gauge, but that would work out a great deal more expensive. I think I paid about £55 for this particular Variac, which is a little bit less than these, but obviously I would have to add the rest of the components to make it usable. At the other end of the scale, we have items such as this one here. This is a Zenith Claude Lyons Variac. This is quite a hefty device, and it's what I have in my Variac box. I have most of my equipment rack mounted, and right at the bottom of the rack is this box, and my Variac is a Zenith Claude Lyons, which fits it in it to the right of it. Rather than just a display for the voltage, I have the voltage coming in. That goes from 0 to 250, and basically showing about 235. The output goes from 0 to 300, because Variacs can actually increase the voltage over the line level as well as decreasing it. So the gauge for the output is a 300 volt. In its set configuration, it will produce about 280 volts. And then finally we have the output current being drawn by the device on test. I fitted an emergency stop, and I have both the normal banana plug outputs, but I also have 2 IEC sockets, and in the centre here is an earth which can go with the other two sockets, and finally an accessible fuse. In the along the top I have my switches to select the features that I want to be using at that particular time. So if I have my device on test going into one of these two IEC sockets, I can select whether or not I want normal mains coming into the device or mains from my isolator. In the center position, this would be off. Once I've selected the place that I want the AC mains to come from, I then select whether or not this goes through the variac or whether it goes through at line level. And finally, I can switch between having it current limited or not current limited, which basically allows me to test an item and select what I want as I want it. I see a lot of confusion on Facebook and forums about what a variac actually is, and a lot of people, even those that have a variac and use it, don't quite understand what it is and how it works. A variac is basically an adjustable transformer. It's known as an auto transformer as well. So in this diagram here, you can see that the A to C mains comes in and it's connected to both sides of the primary of the transformer. The secondary, one side is connected to the same point as the primary, and the center tap of the transformer is adjustable using the knob, and depending on where the knob's turned to, it either increases or decreases the number of turns used to provide the secondary. So effectively, with it in the centre, you get half the voltage and twice the current. So 240 volts in, 120 volts out. If you turn the knob so that it contacts here, about a quarter of the way up, 240 volts in, and on the output 60. Most auto transformers that are designed for mains use actually have more turns on the secondary than the primary. So in reality, this would be more like, say, 200 turns on the input and 250 on the output. That still allows you to get half the voltage, but half the voltage is around about 40-ish%, something like that. But it does mean that if you continue past the number of turns on the primary, you can actually get a voltage higher than the input voltage. And that can be useful for testing over voltages and things like that. So in reality, there are more usually on the secondary. Now that we've covered the theory, I'm going to talk about using the variac in practice. This particular variac, the Ravistat, I've managed to download the datasheet, and this diagram here is the diagram from the datasheet. This letter E that's in the datasheet, you can just ignore that. It appears to be erroneous. E is the live output, A is the neutral output, A is also the neutral input, and D is the live input. So coming from our main supply, D comes to here, A comes to here. I'm connecting the variac up to my bench variac, which is set to provide just over 10 volts, which you can see there. The actual meter is connected directly to the pins, which aren't which are live at the moment, but coming from one of the other outputs is this device here, which just allows me to connect wires directly to the mains. This is fused, and it only energizes when you close it, so it's quite a useful device. The output E and A are going to the second meter. Now if I close this device now, we have 10.4 volts going in and nothing coming out. As I turn the dial, you can see, oh, would help if it was on AC. You can see that the voltage is increasing. And as we turn it all the way around to the far end, you can see that it actually goes beyond the 10.2 volts that's going in to 11.4. So effectively it's going about 10% over, which is excellent because it allows you to do over voltage testing and things like that. So far I've spoken to you about the Ravistat and basically said that this is a non-isolating variac, and connected as per the datasheet, that is the case. In fact, the datasheet itself specifically states this transformer is not designed to provide mains isolation. However, okay, so now we move on to isolating variacs. Now, with an isolating variac, the neutral connections are not connected together. So there's no direct electrical connection between the AC in and the AC out. If we look at the actual variac here, this point here is the neutral on the secondary, so that's here. This point here is the adjustable center tap, so that goes there, and this point here is the point here where there is no connection. So effectively we have the secondary across here, just like it is here. Now this point here, this point here is the neutral input on the primary. Now this is set up to give you quite an adjustable range. In position 4 I get 280 volts out for 240 volts in. By selecting a different tap, you can adjust the range so that you can have a range going lower than 240 and higher than 280. I just find that tap 4 is the best position for me, and that gives me 0 to 280 volts. Before I finish talking about my isolated variac, I thought I'd give you a very quick look at the wiring inside it as well. I've explained what all the controls do, but this diagram shows how they're connected together. So the first switch, as I said, switches between mains, off and isolation, and this is a 3-position switch with the center off. So if either of them are supplying power and it's switched that way, the red light will come on. That then goes to the variac and line switch, and then the current limiter and full power switch, and then through the fuse to the outputs. I've just shown the outputs as 3 round discs. In reality, the blue would be the neutral, the brown would be the live, and the green would be what is there is black, which is just earth. These can be connected up to any range of sockets that you might want. Finally, I'm going to talk about isolators. An isolator is just another type of transformer. In particular, it's one where the windings are the same coming in as going out. This means that any AC voltage going to the input is induced in the output. So if you connect this to 240 volts or 110 volts, that's what you get on the output. But there's no direct electrical connection between the pair of them. So effectively this can float. I'm not going to go into the safety aspects of using an isolator because many people have done that before. If you do want to know about that, I would suggest you have a look at Mark from Blue Glow Electronics. His series on oscilloscopes is very good, and that does talk about the safety side of it. But suffice it to say, an isolator is a very useful device to have on your bench. I didn't get my isolator out because it is about 250 by 250 by 250 millimeters and weighs about 40 kilos, and it's under the desk with things in front of it. So that's staying put. But that isolator is what feeds my bench for the test devices. For the items on test, the actual equipment is connected to the normal mains, so that gives me that element of safety. You can use an isolator before a non-isolating variac to create a fully isolated variac, and if you have bought a variac which doesn't isolate, that's a very good way to give you the fully isolated option. Thanks for watching. Please click on like if you enjoyed the video. Please subscribe. The more subscribers I get, the more chance I have of getting stuff to show you on a further video, and it also means that more people will be told about my videos when they do a search. Thanks a lot. Bye.